Welcome to Python in Education, the series for teachers and students and everyone else. In this video, I'm going to talk about how to use Python as a graphing calculator. Just for context, the video that you're watching is part of this Python in Education series, and you are watching right now this video. So if you're jumping in, there'll be some things that might have been covered in some of these previous videos, like this one and this one. If you want to jump and see any of those videos, just click on the box and it'll take you directly to that video. So in this video, I just want to mention that I will talk about how to use Python as a graphing calculator, but there's a lot of details. Some of those details I'm saving for these future videos, and so you can go find some of the details in there. So some of the things in here might seem a little bit sophisticated. That's fine. Just get the main idea and then go find the details in these other two videos. Okay, and also, by the way, all of the scripts that I have in here, I've put up on Google Drive. And if you look down in the description below, there's a link. So you don't need to type in any of these scripts. You can just go grab it, use them, modify them, do whatever you want with them. Okay, so in this video, I have organized it into a first part, which is why I think using Python as a graphing calculator is better than spending the money on an actual graphing calculator. So watch that if you think you might want to buy a graphing calculator or use Python instead. If you're already convinced that you'd rather use Python instead of purchasing a graphing calculator, then you can go see all of these examples, and you can just click on any of these you wish and it'll take you to that part of the video so you can easily jump around. Okay, so what is the cost of a graphing calculator? Many students around the world need to have a graphing calculator, and these are sort of the rough costs of what graphing calculators are. And so for a really fancy color graphing calculator, you're looking at about $150. And here's an example of a Texas Instruments. It comes with a fancy color display, 3.5 megabytes of memory. You actually can connect it to a computer, and it comes preloaded with some things like periodic table and so forth. So what can you get for the same amount of money? I went on the web and looked around and immediately found that for the same amount of money, I can buy an entire used computer system with about 1,000 times as much memory, a screen with thousands of times more pixels than this, and because it's a full computer, I can connect it to the internet and have access to all of Wikipedia, all word processing and presentation software like Pages or Word or PowerPoint or Keynote, educational software. There's no limit. So if I'm able to use this as a graphing calculator, I get all of this capability with much higher quality and everything else. And so you can ask yourself how you would rather spend that much money. Not every student has $150 in their budget to spend on a graphing calculator. So I think Python can solve that problem. Okay, so what's the quality? So this is the graphing calculator that I used when I was a student. It's an old one. And when I bought it, it was expensive. It had limited functionality. You know, it has some stuff, as you can see there, trigonometry and so forth. It was pretty awkward to program. And the graphs were crude. This is like a sine and a cosine plot. And if I wanted to export this to something, it was pretty challenging. So challenging, I think I probably never did it. In fact, the quality is so low, I'm not sure I would want to show it to anybody anyway. Now, in the modern world, this is what graphing calculators look like. You have this fancy 3D plot with a mesh. You have color graphs here on the right on this nice pink calculator. And so you can do things that are a little bit better, but still, you know, imagine you want to enter an equation that looks like this. They're still a little bit awkward to use, but they still have these fairly, you know, better graphs than they used to. Okay, so why would you want to use Python instead of one of those? There's many reasons. One reason is that Python is free. So the cost is pretty good. You can go out and get it off the web if it's not already on your machine, and everything I'm going to show you in this video will cost you nothing. It's a programming language, and that may be intimidating for some students and some teachers, but don't worry, it's a programming language that if you use it like I'm describing in this video, you need to learn a few commands. There is a learning curve. just like there is with a graphing calculator, but I feel like the learning curve for this will pay off much more than learning how to use a graphing calculator. It's really easy to learn. Python was invented based on a language for teaching, and it was meant to be a language for everyone, and it's used by a very diverse set of people. But importantly, you don't really need to know that much. With very little knowledge, you have a perfectly good graphing calculator. In fact, I would say you have an excellent graphing calculator with almost no investment. So don't be intimidated by those sorts of things. Python contains all of the math that you'd ever want, including complex numbers, beyond anything you can imagine. Everything is available. It's trivial, basically, to export the plots and save them into Keynote, PowerPoint, whatever you want, put it on the internet, put it in an email. It's literally the click of a button, and I'll show you how to do that here in a minute. You can store values and variables. You can define your own functions very easily. I recommend watching the video that precedes this on just using Python as a basic calculator to see how you can do some of that. Here I'll really focus on the graphical part. The other thing that's nice is the complicated operations that you might be doing to make these graphs can be grouped together in scripts. And what's nice about that is you can save them and use them later. And so I'll show you how to go into an editor, make a plot that you can save that file, bring it up later, modify it, or send it to someone else so that they can use. It's really easy to do in Python. Now, what's also a very nice feature is if you want to use Python for actually learning programming itself, which is, of course, it's a programming language, you can also do that. In fact, this is a nice way to learn Python in a gentle way in use in all classes, and then later you can actually use it as a full-fledged programming language. There's really no limit to how you can use this. Okay, so there's some more reasons, and that is simply the quality of the graphs. Here's a graph that I made with Python. It has nice color. You can change the color. It has axis labels. You can change those. You can put error bars. This is great to use in a science project, at a science fair, or in a lab, physics lab, biology lab, chemistry lab. You can do this kind of plot very easily. And so watch the other videos in this series, and I'll walk you through in detail how to do these things. Very simple. You can even do things that are very beautiful, like these contour plots if you're looking at functions in 3 dimensions. Very easy to do and very easy to customize these sorts of things. Learning can be easy. If you're a teacher, if you're watching this video and you're a teacher and you want to teach some part of math like trigonometry, geometry, or calculus, you can actually customize your plots that fit with your lectures or what you're thinking or the problems that your students are having. Here I have an example that could be used, for example, in a calculus class. Also, the other nice thing is when you're using Python, it will pop up a GUI, a graphical user interface, when you make your graph. And what's nice about that is at the click of a button, this button right here, I will show you how to use this later, you can save this plot into a graphical file that you can just drag and drop and send it anywhere in email or use it anywhere. Literally beautiful plots, and in the click of a button, you can have this plot anywhere you want it. Okay, so let's just review. Graphical calculator on the left, Python examples right here in the middle. The nice 3D plot that you have on this calculator, what would that look like if you did that in Python? It would look something like this. So very nice surface plot, a contour beneath it. Press a button, save it, and send it wherever you need to send it. Okay, so how easy is this? So there's 2 reasons why Python creates a capability for a graphical calculator that's so easy. And the first one is it's an interpreted language. There's no compiler. You don't need to compile it and find the executable and execute it. You simply type a command on the screen and it just does it. And so you can type a few commands on the screen and pop up a graph and click a button on the GUI and save it, and you're off and running. So that's one of the reasons this is just so easy and everybody should know how to use this. The second reason is that it uses libraries or modules. Python itself is a small, compact language, and you can read in or import capability. And so what makes this such a great capability is there's a huge toolkit out there, a toolbox called Matplotlib. And what you do is you simply import it. And once it's imported, all of that capability to make all those graphs that I just showed you are now at your fingertips. You simply have to type something like PLT right before you use the command, which I'll show you that now. So let's go into Python here. Let me move the window up. Okay, type Python at the prompt. And now I'm in Python. I'm in the interpreter, and I'm going to import matplotlib.pyplot. And don't worry about what that is. You're just going to type that every single time. So just memorize it as PLT. And you can make that PLT whatever you want, but that's very conventional. You'll see that on the web a lot. Now what I do is I take my data from my science project and I type it into a list, which is separated by these square brackets. Now I have my data and I tell it to plot pulling in from PLT. Now it made the plot, but I need to show it. So I tell it to show it to me, hit return, and it pops up right on my screen. Let me pull it over here so you can see it, and there it is. That is how easy it is to plot data with Python. Now it pulled up this GUI, so you can see here at the bottom there are some options that I have available to me. Like one of them here I can use to zoom in on a part of the graph once I've made it, and then it'll replot it and I can see it up front. But here's the amazing thing. I press this button, which is save, and then I can simply give it a file name. And now the file has been made and I have a PNG file sitting on my desktop, and here it is, and I can do anything I want with it. That is how easy it is to use Python to take a data set, put it in a list, make a graph, and save it to the computer. Okay, now that uses the Python interpreter very directly. In a previous video, I talk about using an IDE, or an interactive development environment, which is a little bit easier. And the one that comes with Python, so it's completely free, is called idle. Now, one of the nice things about using idle is I can use it just like I showed you here, but I can also put all of those commands in a file and save them for later, which means I don't have to remember some of those things. I just come in and modify it. So let's see how to do that. So let's go into idle. So I type idle. This assumes you have Python installed. Idle will be there. And idle pops up. And here's the interpreter. I can use it as a basic calculator. I always do that just to check to make sure everything's working. But if I want to save my commands in a file, I'm going to open a file, a new file. And then here I'm going to type in all of my commands. And again, don't worry too much about what these commands are. I cover them in subsequent videos. But this is the one that pulls in the graphics capability. I'm going to use another set of tools here called NumPy. And I use that because it's really good at making lists or arrays that are very easy to do for mathematical operations. Here I'm using it to set up an array of x values between 0 and 3 pi, and I want 100 values in there. Very nice for plotting functions. So let me plot NumPy's version of sine x. I'm going to call that ys, and then I'm going to call up NumPy again, cosine x, and that generates now 3 arrays, x, sine, and cosine. So now with one line I can plot all of that, x and yx, s, x and yc, and then I want to show it. And that's it. Now this can be saved in a file. But what I'm going to do is I'm going to run it just to show you that it works. I save it in a file, give it a file name, and save it. Okay, and you'll see the name appear right up here. Notice where it says untitled, turned into a file name. Sorry that disappeared so quickly. But now it's in a file and I can go modify it. But now it's running and there's my plot. So if I'm trying to learn trigonometry or teach trigonometry and save it in a file, I'll call that file sine and cosine. And that's for the graphics file. And then now I can go do whatever I want with that file. So that's an example using idle, which allows me to use the idle editor so I can save that file and go back and change it. Maybe next time I want to do cosine and tangent. And so I just modify the file. And it also helps me so I don't have to remember those commands that may at the moment seem complicated to you. Okay, so here's a much more complicated example. And again, this is all covered in detail in subsequent videos, but let me just walk you through just to show you how easy this is once you get used to it. So in the beginning, you're always going to import some things that allows you to use the graphics capability. Then there's a set of commands where I set up the x-axis. This is where I want the points to be plotted and how many points I want. So you use that all the time. You'll have that in your file. And then these are the functions I want to plot. I'm using here sine and cosine again. But now, just to contrast it with the plot that I just made, I'm going to make two plots so that I can see them side by side. And this is a very common thing if you want to compare two different things, but you don't want them right on top of each other. So Python, or matplotlib more particularly, has this great command called subplot. When I call the subplot command before I make the plot, tells me where to put it. So this puts it in one position, this puts it in a different position. And I'm also showing you how to customize it. I can add labels, X labels and Y labels, very easily, and then I can show the plot. And so what would that look like? It looks like this. So again, if you have a script like this that I just showed you, you can simply go in and modify it and make plots that are, instead of one on top of the other, you can put them side by side, or you can have 2 by 2. You can make any arrangement of plots you want just by modifying this simple file. So very flexible. And all the codes, by the way, I've stored up on Google Drive. So you can go to Google Drive, you can download this file yourself, put it in Python, start playing with it, modifying it, use it for whatever you want. Okay, another capability that you might be interested in if you're teaching or learning math is how to do things in different coordinate systems, and of course Python can do that as well. So here's an example. Again, you're always going to import these, so you just get used to doing that. And now I'm going to use a different coordinate system. I'm going to define angles from 0 to 2 pi, and I want 300 of them. And then I'm going to stick that into this function here, which happens to be sine of 3 times theta, and put that in my radius variable. Okay. And then this command right here tells it to use a polar plot. So whenever you want to do a polar plot, you just execute that command. Now you know how to do it. And then you make the plot. This makes the plot. This sets up how far out you go in radius. This adds a nice little grid. It makes it look a little bit beautiful. It's always nice to have a title and then show me the plot. And here's that plot. So very easy to make polar plots if you're learning different coordinate systems, or even for complex numbers, whatever it is you're doing. You have available to you all these commands to do these kinds of plots. Okay, let me give another example, which is linear regression. Now this is where using Python as a graphical calculator becomes extremely powerful, because it's not just a graphing calculator capability that I'm showing you here. It is a full scientific capability. So let me show you how that works, not in detail, but just give you the spirit of how it works. As usual, we're going to import these libraries. You're probably getting used to that by now. Now, what I have here is I have some data. Suppose I do an experiment, and these are my time points, let's say, and these are my data points. So what I do in Python is I store my time points where I took my data here, store the data here, and then I'm going to do these two commands. Don't worry about how they work for this video. I'll have another video later that talks in detail how this works. But just know that the capability is there, or just copy this. Then this just sets up the plot. You know, make the plot of my data, plot the fit, put all the labels to make it readable by other humans, and then make the plot. And so here's an example of the blue circles are the actual data, and the line is the result from the linear fit. And as you can see, I have some customization in here. Like I have, this tells me to do circles. I put a label here and a label here, and then it knows to make a legend, which is very useful up here, and very nice. And so what I typically do is I will go grab a file that has all of this capability in it, all at the bottom, all this capability at the top, and then I just start filling things in between and then customizing it. In a matter of minutes, I have a really beautiful plot like this. I press that save button and I'm done. Okay, so that is the end of this video, which introduces you to the concept of using Python as a graphing calculator. I hope you're convinced that it's a really great way to have a graphing capability. It's free and better than any graphing calculator that I've ever seen. If you're convinced, I recommend then going to see these videos next, because those videos have more of the details of how to make these plots. I walk you through and talk about some of the details in a little bit more of a tutorial way. If you want to jump to one of those, just click on the box to jump there. And if you want the actual code, as I said earlier, you can get all the code right off of Google Drive, so you don't have to type anything in. Okay, great seeing you here. Hope to see you back here very soon.